Today we'll solve a math problem from SAT. This is question 36 from section 4 Math, Calculate Aloud. The problem is very simple to solve, but it is good to know a clear algorithm of actions to solve such problems quickly. We are given a system of two inequalities. In the plane, if a point with coordinates a, b lies in the solution set of the system of inequalities above, what is the maximum possible value of b? We have two inequalities with two variables, and it looks like the solution set contains many points, and we need to find the point which has the maximum possible value of y. Let's try to graph this problem in the xy plane. And first, let's graph the boundary lines of the solution set of both inequalities. Let's take the first inequality and draw the boundary line of its solution set. It's minus 15x plus 3000, and this is a line graph. For this line graph, if x is equal to 0, then y is equal to 3000. So, 3000 is the y-intercept for that first inequality. Minus 15 is less than 0. This means that the line graph has a negative slope. Let's draw a straight line through the point with coordinates 0, 3000, which has a negative slope. The solution set of the first inequality is represented by the half plane below and includes the boundary line. Let's take the second inequality and draw the boundary line of its solution set. It's 5x, and this is a line graph as well. For this line graph, if x is equal to 0, then y is also equal to 0. So, the line passes through the origin. 5 is greater than 0. This means that the line graph has a positive slope. Let's draw a straight line with a positive slope through the origin. The solution set of the second inequality is represented by the half plane below and includes the boundary line. The solution set of the system of the inequalities is the intersection of these half planes, including the boundary lines. And the solution AB with the greatest possible value of b will be the point of intersection of these two boundary lines. If the first and second lines intersect in the point xy, this means that 5x is equal to minus 15x plus 3000. Let's solve this equation. Let's add 15x to both sides of the equation. Now we have 5x plus 15x is equal to 3000. So we get 20x is equal to 3000. Let's divide by 20 both sides of the equation. Now we have 20 divided by 20 times x is equal to 3000 divided by 20. So we get that x is equal to 150. This is the x-coordinate of the point of intersection, but we need to find the y-coordinate of the point of intersection. We know that the y-coordinate of the point of intersection is equal to 5x, and it is also equal to minus 15x plus 3000. Since x is equal to 150, we get that y is equal to 5 times 150, that is equal to 750. This is the maximum possible value of b for a point with coordinates a, b lying in the solution set of the system of inequalities above.